Full screen. Okay, so resuming from where we left. So we are talking about a quality program. So quality program is essentially the written description of the organization structure, responsibilities, activities, resources and events that together provide organized procedures and method of implementation to ensure the capability of the organization to meet quality requirements. What usually we are having the practice is that we work more on instructions, and many a times we feel that we are poor in documentation. But documentation is really important. Why documentation is important? Documentation is important not only because it helps you guide what we are doing as a quality manual, but it also saves you at certain positions wherein your actions may be challenged. For example, you are working as part of a quality assurance team, and you find that there are certain discrepancies in the works which are being carried out, and you maybe put an objection to it. So then what will happen is that the people who are into the construction team will try to say, no, your objection is not valid. Or maybe you may be told that you are taking a decision which is based on your wishes only. At those places, this document, which is called the quality manual or the quality assurance manual, comes into our rescue. Basically, as a quality assurance person or a quality control person, I'll say that most of the time your work becomes more mechanical. Means you say that I want a density of 1.75. So you are going to see at the in situ density values which has been recorded in the field, and mechanically you will be saying at these particular locations or at these particular instances the density which was required has not been achieved, and so out of maybe 100 instances 50 instances are wrong, or 20 instances are wrong, or 10 instances are wrong. At that particular time you are not going to have a consideration of stating that okay, 1.76 or 1.75 or 1.77 are the same. Therein you are going to stick to a value. Value means value. 98% of a density, if that is required as per the quality manual, you will stick to 98%, not 97.8%. Okay, because this 98% in itself has some inbuilt percentage of error, and if we are going to err on the error side of it, then we are going to really compromise on the quality. So there is a British standard by the name BS 4778. It defines a documented set of activities, resources and events serving to implement the quality system of an organization is called a quality program. Then we need to work on the quality plan also. And in this document, it is desired from the quality program, setting out of specific quality practices, resources and activities relevant to a particular contract or a period. The quality plan usually includes the quality manual, the relevant quality procedures and requirements specific to the particular contract. Means procedures and requirements. In requirements, it can be varied. We'll be coming to a case study. Therein, these things will become more clearer to you. Responsibilities, okay, it covers all stages of the design and construction. The quality assurance organization has to take care of all the stages because uh, many a times the sequencing of activities during the construction of any project may also lead to its failure or will be leading to its success. So the sequencing and the progress of each of these activities, if we remember, maybe like we talk about CPM part. So in that, there we are identifying what are the critical activities. So there at that particular time, the sequencing of these activities are interrelated, and any flaw in one of the activity will basically affect the whole progress of the project. So QA organization will be responsible for various factors, facts such as QA plan and procedures, QA on works, quality control on materials, testing and quality audit. The QA manual, it will provide basic understanding and the need for QA, broad guidelines and procedures towards an implementation, effective implementation. You may sometimes question that, okay, there are standard sets and practices, there are standard codes. Suppose, for example, yesterday we discussed, okay, in order to determine the grain size distribution. So there are standard code of practice. The IS code is there. So, okay, we'll say that, okay, we'll be following the standard code of practices for that particular item. But at times, you may be having certain variation in the material as per your design requirement. So, you have to evolve a special method for evaluating. I am saying even a simple thing like a grain size distribution or even the density of the material by some special method. So, that all things will be coming into your guidelines. Sample formats, checklist to be used by the field staff, QA staff and contractor to systematize day-to-day working and testing procedures for frequent encountered field and laboratory tests. Mostly we have seen in many of the projects that we become more focused on the work than on documenting it. So work is going on, but and maybe some data is also recorded, but we are lazy to record it back into those registers, thinking this is a very mundane job and it's a very clerical job and it is not at all required. As engineers, we are doing our job correctly and we should not be focusing on these things. But it has both aspects. It comes to your rescue also when certain things go wrong, and it also gives you appreciation when the whole work is get completed. Many of our best works, we don't have documentation of them, and so it is only in the memories of the people who were actually involved in that project. And once those people move out of that project, that history which was created has no place. So that's why the documentation of all these things is very important. Major functions of the QC department: to ensure association with engineer in charge and design organization, establishment and compliance of contractor quality assurance plan at site in accordance with the technical specifications of the contract, to check out the various stages of execution of site work such as survey and setting out excavation, earthwork, fill work, geological logging, stability of underground works, rock support, concreting, etc. So the QA team has to be involved in every aspect, whatever it is going on. Sometimes when we are new to this field, we have been told that, okay, you have to go to the lab, see whatever testing is being done, see whether the records are okay or not, and then your work is over. But no, every facet which is going up, every activity which is going in there, everything is to be looked into by you, claimed by the contractor. All these aspects are being looked by the quality assurance people. To analyze results of QA works, records highlight problems, records, highlight problems areas, and suggest remedial measures. Sometimes as a QA team, you alone may not be in a position to suggest the remedial measures. Then you have to work in tandem with the designers. You have to bring the problems to the knowledge of the designer that such and such thing is happening and require certain design intervention or certain correction in the construction procedure or certain deployment of additional machinery or manpower. So that all have to be done by you. Then documentation and follow up, analyze and report to the QA division. Quality control, basically we can have, we'll be talking about the functions, inspection, testing and reporting. So what is the function? Setting up standards and specifications. As I was saying, you may be having numerous standards for the same parameter. But which particular standard is to be selected, that you have to see. Evaluating material processes and output through appropriate tests, inspections, etc. For example, we take the construction of a earth dam. Okay, and for the earth dam, we say that okay, first of all we have to identify the bore area. Fine. From the bore area, we know that okay, particular type of material is to be collected and used for construction. Now, two methodologies can be used. Either I am directly boring from the bore area, or I am creating stockpiles, and from the stockpiles I am going for the construction. So in case you are going to directly borrow from the bore area, you need to know what is the moisture content of that material in the bore area. Then you know what is the optimum moisture content which is required during construction. So you will see whether the contractor has calculated what amount of additional water is to be sprinkled on that material, whether the method of sprinkling of that water on that borrow material is adequate or not. Is he taking proper care of that? That you have to see. Then when that material is being put on the construction site, whether it has been evenly spread or not, whether the rollers, whether proper thickness of that layer which has been dedicated as per the design drawing, that is put. For example, we say that I'll be having a layer of clay of 30 centimeter uncompacted, and I'll say that the compacted layer will be of maybe 22 centimeter or 23 centimeter depending upon the density. So as a quality control team, you have to see that the layer is not more than 30 centimeter. Why not more than 30 centimeter? Because the impact or the effect of the roller, it also is going to penetrate to a certain depth only. The density will be varying with depth. If suppose if the contracting agency is providing a greater depth, suppose they put a 40 centimeter depth, and you are going to go in for a maybe a lower density, then again we are having a higher density, again varying to low. So we are having thin zones of weaker material there, which is not compacted to the desired density. So ultimately they are planes of weaknesses. And when these planes of weaknesses are subjected to that water load, they may lead to erosion of the material. So it is, and usually what happens in the wake of the progress, you'll say 30 centimeter or 35 centimeter or 40 centimeter, everything is okay. But as a QA personnel, you need to have that critical eye of seeing, no, this is not 30 centimeter. You have to stop it and get it corrected. Quality assurance people are not a welcome at this site. They are the people who are mostly looked in upon, the people not wanted. But you have to play that role, and you have to play that role whenever it has been given to you. So evaluating material processes and output through appropriate test inspections, planning improvements in standards or oblique specifications. It is during work itself that you will be able to understand that okay, this particular type of material testing procedure is not adequately fitting to what I am requiring. Then you have to work on it. You have to tell in, you have to discuss ki maybe if we change this method of testing, I may be getting some better results or some better way or to evaluate what type of property I am trying to evaluate. Inspection, you have to go in for site inspection. It forms a critical part of any quality control plan. Establishment of field and laboratory testing facility. This is very important. What usually we have found at many projects, that for example we are talking about a grain size analysis program. Now the project people, they say that they have established a quality control laboratory, and maybe they have established a quality control laboratory which in which you can do a grain size distribution using the pipette method, and maybe they are having only two cylinders and one pipette, and during the process of testing that pipette gets broken. Now the whole quality control program comes to a halt. So as a quality control engineer, you have also to see whether adequate number of those testing facilities are available. Is there a backup plan? Do they have more cylinders or not? In case they don't have cylinders, how easily they are able to procure it? Because usually the construction sites are in remote areas, wherein maybe you may be getting a cylinder maybe in 5 days or 10 days, or maybe you are at such a place where you can get within a day also. So all those things also you need to put into picture and then plan accordingly. These are very minute things, but they require very dedicated planning and execution. Suppose what if I'm going to get 5 samples at a time. If I'm going to have only two cylinders, maybe I'll be able to test only two. And maybe yesterday, I think Mr. Shahid might have told that for settlement of clay particle, how many hours it is going to take? How many? बताइए, आपका क्वेश्चन होगा ये, कल पूछा जाएगा आपसे. For settlement of a clay particle, how much time does it take in the settlement in that pipette analysis? Basically, suppose that is X hours. Let us take, I'll not give the answer. Suppose that is X hours. So basically, my test will be completed in X plus some T hours. Means, if I'm going to have 5 samples, so it is not less than 2 to 3 days, I'll be able to complete one test. Okay. So this means, as a quality control person, I have to look into that adequate number of testing facilities are there in the QA lab. Normally, we have come across a situation in which it is hilarious also. That particular project, they used to have a hydrometer. And we told them that you should go in for a pipette analysis. Why pipette analysis? Because hydrometer has many corrections to apply, and it can be more errorful as compared to pipette analysis. So we at CSMRS always say that we should go for pipette analysis, and even the IS code also prefers the pipette analysis instead of the hydrometer analysis. So whenever we used to visit them, they used to bring a brand new hydrometer in front of us, and they used to say that, sir, we are using the hydrometer for the grain size distribution. So I asked, if we are using the hydrometer, for your hydrometer should be a bit old, it's brand new. So he said, no, sir, actually, yes. I mean, they used to tell us some stories. Sir, yes, sir, we just were using it. We are just training ourselves and all those things. Okay, fine. Then after 2-3 months, when we went back again, this time they bought a old hydrometer. Okay. So when he asked, okay, now how you are doing the grain size analysis, they said, sir, we are using the hydrometer. Okay, me show us the apparatus. So they brought out that old hydrometer. So then we asked, now you are using this hydrometer for using this pipette analysis, this grain size. Yes, sir. Yes, sir. Sir, you told na we are having a new hydrometer. So now we got an old hydrometer. But there are people they do that way, because basically they feel that quality control is an area which is to be neglected. They feel it is to be neglected. It is not neglected, it is to be neglected. They don't want to go into those areas. So, your role will be to achieve the required quality, to ensure that quality is being maintained. Definite quantifiable means of rejecting substandard work. If your work is substandard, you have to reject it, and those parameters should be there in the manual during the inspection, and you should say, okay, this is not correct means this is not correct. Testing for selection of areas of materials, testing may be done in two ways. Selecting those areas to be least likely to meet the specification requirement. When you are visiting the site, you often tend to develop a critical eye. During the visit, you are able to identify, okay, those areas, suppose that is near the abutment. So you identify, okay, that is the place where the roller is not being approached. So that area, maybe the density may not be correct. So you will simply say, okay, let us have a sample at that particular place. Now you will say, okay, then when the roller cannot be compacted, so we have rammers, we have handheld devices for compaction. So those can be used. They have to be there. Also, when you are visiting, you will be able to understand. You may simply ask, "Achha, where is your handheld device?" And maybe the person who is in charge will be able to tell you the correct method, the correct thing. They will tell you the fact. They will tell you, सर वो तो अभी रखा हुआ है, उसको अभी सर परसों एक बार निकाला था, लेकिन वो चला नहीं. They will tell you the correct position. So that role you have to play. So you have to select those areas. You have to reduce the quality of testing. The above selection, however, requires experienced inspectors or engineers. As I was saying, that it is when you go time and again, you are able to identify, okay, this area I have to look, this I have to look at. Selecting test areas at random to achieve minimum recommended frequency to reflect overall condition of the construction work. Usually what happens is that when we are trying to say what should be the frequency of testing, so it is always a tug of war between the quality control and the construction team. So construction team says that if suppose, sir, if they are going to test every hour or every 2 hours or every 5 hours, our work is going to get stopped. So we will allow them to test only once in a day, or maybe once in 2 days. That is how you come to final an agreement. Okay, maybe once a week and we'll do a test. So therein your experience is required to identify zones wherein there can be lack of quality, so that you are able to improve upon these things. And quality people are not to stop the work, they are to improve the work. And that is to be told to the constructing agency also. Okay, we are here to improve the work, not to stop it. So that finally we are getting a thing which is really serving its purpose. So minimum frequency has been identified. So your experience becomes very important there. Then reporting. Complete construction records should be maintained. These are required in the event of repairs or modifications, raising of the embankment height in future, surveillance during the life of the dam, contractual and insurance claims. You will say, okay, we have constructed a good dam, it is functioning fine. Now what is the requirement of all these documents? The work was good, everybody was satisfied. Suppose it is a dam with power production. Power production is also up to the mark, and water storage is also there. Seepages are very nil within the limited quantities. The deformation of dam is within the 1% or 2%, whatever we have decided. So what is the requirement? So it is required in case of modifications or repairs. There may be a requirement of raising the embankment height. At that particular time, these documents become very important for the designers to decide what type of material has been used, whether we can really go in for enhancement or not, whether we have to put the same section or the section has to be increased, whether the foundation treatment, what is the extent of the foundation treatment, Do we need to go for more foundation treatment, or the same is going to be adequate? What was the pattern of the foundation treatment done? All those things, all those small tiny things which at the time of construction are of no importance, they become very important in those periods. Surveillance during the lifetime and contractual and insurance claims. Reporting should include plan specifications, including amendments during construction. This is also one of a major problem which occurs. One construction drawing is issued, then there are amendments. Now, because this amendment has been made at the last moment, so this drawing sometimes is missing in the records. The amendment drawing is there with the constructing agency. He does the amendment based on that amendment drawing and the project is completed. And this does not become the part of the record. So finally in the record what is available? You are getting the original drawing which is there. And the amendment goes down the memory lane. So nobody remembers. 5 years down the line, some people go and visit and a construction drawing is placed before them which shows the original section. So what has been constructed gets missed. Now suppose the structure is failing, is having certain distress. Now you are going to visit there as expert. Expert has been shown the drawing which has not been used for construction. So now you are going to base all your decisions based on that drawing. You will be giving some remedial measures, but actually the structure is in a different mode. So all your remedial measures are going to be not effective to that level up to which you are thinking. And you are now doubting your engineering judgment. That after 30 years of my experience, how is it that I am not able to judge this problem and give a solution which should work here? The error was only a very simple thing, that the drawing which was used for construction was not kept in the record. Very small thing, but having very big implication. And technical meeting reports, report from dam review panels, QC test reports, daily reports by all supervisory personnel. Slightly we'll touch upon what are the requirements of the core material. It should be well graded. What is a well graded material? That has been discussed. What is a well graded?
Well graded material that consists fault size.
A material which is not gap graded is a well graded. Then it should be impervious. It should have low permeability, non-dispersive, low erodible. Why low erodible? Low erodible is not the requirement. We say that it should not be highly erodible. So it should be non-erodible to maximum of a low erodible. Okay. Don't say that, okay, I have to search for a material which is to be low erodible. Okay. So this is how things have to be read. Then flexible, low compressible and good shear strength. These are the basic requirements of the clay core material. And quality control of embankment materials for the core material are broad guidelines. These requirements may be changed based on the project condition. Then in the compacted impervious core embankment, bulk density you have to determine, water content not less than 3 per sample or layer, permeability in vertical direction, shear strength 1 in 10,000 cubic meter you can go in for. See, shear strength and compression characteristics or consolidation characteristics, they are not much required because they have been evaluated previously and they have been used in the design criteria. But bulk density, water content, regular method to ascertain whether the construction procedure is correct or not. The locations or spots from where samples are taken to be fixed by 3 coordinate elevation. Why 3 coordinate elevation? Because that is the way how you will be able to understand where you have taken the sample from. This is my clay core. This is the length of the dam. you are going to construct it in layers. So the elevation is should be known to you. Then from where you have taken this? From the right abutment or the left abutment? From the edge of the core, how much? So best is you go in for a total station, and then we can plot it back in a 3D system finally, so as to understand, okay, have we able to cover the whole system or not. So that is very much required to give confidence. One control pit with depth not less than 1 meter should be there in the clay core, which is to be backfilled again to the same density in layers. The walls of the pit studied carefully with regard to density and water content. Excavated pit after inspection shall be restored by new material. Compaction shall be carried out by vibratory plate so as to achieve the same density and moisture content of the compacted envelope. In one project we had visited, I'm sharing what happens. We visited the project, and their instrumentation was being carried out. And what do we do in instrumentation? The instruments are placed in the clay core and the shell and the filters, and finally the cables have to be taken to a center wherein you are going to have the data collection center. They had dig below the FRL in the clay core. They were taking the instrumentation cable, and then when we asked them, Acha, how you are going to fill it back? So they just have told, sir, we'll be using the same material and we'll just fill it. And how do you are going to achieve the compaction? Now these are instrumentation people. They know nothing about compaction. So they just explained to us, sir, it's only मिट्टी, इसमें कुछ नहीं होता है, ये तो इसमें हम डाल देंगे और इसको बस ऐसे ये हो जाता है, इसमें कोई बात नहीं है. So we immediately said, okay, you stop. You please talk to the design team, talk to the construction team, and evolve a procedure. Maybe if it is not possible, use bentonite at least, because ultimately we require a more impermeable layer, because those are cables, those are zones of weaknesses. Compaction cannot be done to the maximum extent there because it may damage the cable. So you need to provide a material which is really more flowable and more impermeable to surround those cable regions. So this is how things happen, because by that time the QC people have also gone. Dam is complete, it's nearing finishing, and only the instrumentation people have come into picture. Those are places, or those are times wherein errors get created. So that is important. And one more thing which our projects are really missing is that handing over of things. We three as a team are working for constructing. They are working for the maintenance. Now, first of all, we are being moved out from the construction going to a different project. So now we are focusing on that project. They are being posted as maintenance team. They are not happy because they want to be in the construction team. So they come in with half heart. And then they just ask, Achana, what is to be given to us? Then we people tell us, these are the documents. Isko aap le lijiye, you sign it up, and then they will hand it over to it. And maybe after 2 or 3 or 4 or 5 weeks or a month or so, then they start looking at these documents. Okay, what are these? And what really gets missed is the instrumentation data at many times, because nobody really is going to take care of that. They will tell us, okay, these are the basic parameters. This is the height, this is the this is the spillway capacity, this is the power generation. Those are the major components which the maintenance team is looking at, and that becomes a big lacuna, and which everybody has to look into. So the contact zones, bulk density, and water content, these are the two major things, because the density and moisture content. So you know the dry density, you know what is the achieved density, the OMC. So from there you go to Proctor density. This is how these things get related. For filters, you need to have the grain size distribution and density and permeability before placement and after placement also. Bulk density by sand replacement method. Why by sand replacement method? Not by core cutter method. You can evolve the density by core cutter also and by sand replacement. Why do we prefer sand replacement for filter materials, and not core cutter method, because they are granular materials. So you cannot contain them in a core cutter. Okay. So if you will be driving a, first of all, it will be very difficult to drive the core cutter, and secondly, even if you drive the core cutter, if you are going to take it out, it will slip out. So you go in for a sand replacement or a water replacement method. Better it is we go in for a water replacement method than water content by over drying maybe one sample per 400 cubic meter. General requirements: impervious recommended grain size distribution should be known. No oversized material should be there. Impermeable meets the requirement of physical and mechanical properties. These from the borrow area to the stockpile to the placement site. So you are having three locations wherein as a team you have to be vigilant and see that the correct material is being excavated and transported to the site. Filter material, it should be free draining, conforming to specified grain size distribution, free from organic or undesirable materials, and meeting the requirement of physical and mechanical properties. Then we need to go in for trial embankment. Why trial embankment? Because through the trial embankment we'll be able to simulate the laboratory density in the field. In the laboratory you had a density by Proctor. Now finally you have been asked, or the design is based on that Proctor density, and you have to achieve that Proctor density in the field. So how do we achieve? Two things we are going to fix. What should be the thickness of the layer and what should be the number of passes of the roller. So once we identify the roller which we will be using based on what is available with the contractor, we will be optimizing the number of passes. Whether we go in for 8 passes, 9 passes, 10 passes, 11 passes, 12 passes. How many passes of the roller they are going to be there on that particular fill to achieve that density for which we have designed our structure. So you have to decide the number of passes to formulate quality control measures for the main embankment. To decide number of passes, formulate quality control measures for the main embankment as such. Means density also you will be seeing, moisture content also you will be seeing there. Again, for impervious material, we need to go in for bore area management, their moisture content, moisture control, exclusion of non-suitable or less suitable materials, deployment of appropriate excavators or earth moving equipments. Moisture control, you are going to check the moisture at the bore area. Again, as I was saying, you calculate what is the additional moisture which is to be put in, or in case the moisture is more. How can the moisture be more in the bore area than the OMC? Can it be more? It can be in case there has been a rainfall. Okay. Suppose, see your construction activity is going to be throughout the year. So suppose there is a rainfall, maybe the top layers have got saturated, or maybe suppose there is a rainfall for a long time, then even deeper depths of the bore area material get saturated. So you may be getting a bore area material which is having moisture content more than the OMC. So then what you have to do? You have to basically get it dried. You have to spread it out so that it dries. Or maybe during the rainy season, you have to stop your construction activity. So that is how you have to control it. Then exclusion, as I was saying, deployment of appropriate excavators or earth moving equipments that you have to see. During placement, thickness, number of passes, overlap. 5 meters at the junction of two reaches and 30 centimeter adjacent passes. This is a long dam. Now you cannot construct it in one part. So you will be having maybe a reach going up to here and then another reach from there. So you will be having overlap region this way, as well as you may be having adjacent passes. So you will be having an overlap here. So as a quality control, you will be seeing that whether this overlap is really maintained or not. A simple method is, maybe once this has been laid down, you may be using a line to demarcate it, or maybe some thread type of things to demarcate with pegs. Okay, this is my 30 centimeter, this is my 5 meters. Because removing that is again it is time consuming. So those are regions where the construction agency will not like to do it. So that we have to see. In situ density moisture content, grain size distribution, Atterberg limit, shear test when required, consolidation test when required, and next layer is to be allowed only after achieving the desired density. That is to be the job of the quality control personnel. Filter material, it should be coarse and fine filters, then placements, layer thickness, again compaction efforts, in situ compaction density, grain size distribution, and permeability. All these tests have to be carried out. So, as a quality control personnel, if we are posted there, it is a very continuous process that we have to do. Rather, you have to create a timeline wherein you will be fixing, okay, 12 o'clock we will be taking a sample of the filters, 2 o'clock we will be taking a sample of the clay core, 5 o'clock we will be doing an in situ density of the filters, and this time we will be doing a density at the clay core, and the clay core sample will be taking 2 to 3 days for the whole grain size distribution. So it will be after 3 days that you will be able to pass this layer. So that will be deciding my construction schedule, and so that this layer, when the next layer is going to be coming on this particular layer, 3 days have been passed so that the work is not getting stopped. So that is how the whole construction schedule has to be maintained. So construction schedule, your quality assurance, everything should be in coherence. And how do we do? Some of these tests in the next lecture he will be taking. I'm just broadly telling. So dry density, we have IS code, so in place by core cutter method. Dry density of soils by sand replacement methods we can go in for. Then rubber balloon method is also there. Ring and water replacement method. This ring and water replacement method is the most preferred method which we usually recommend to people, because there the error chances of error are bare minimum as compared to sand replacement or rubber balloon method. Core cutter method also is a relatively exact or relatively better method, but this is only for clay cores. But in case of filters, the core cutter are not going to function. Nuclear density moisture gauge method, these are rapid methods, but they have their limitation. Nowadays people have been moving into it, but we get scared by the word nuclear, so people usually do not try to move into those parts. I'll not go much into details of this determination of water content. It's 2720 part 2. It's having a lot of methods. Alcohol method we have removed now during the revision, because we found that people misuse this method. And in the course, as I was saying, in the laboratory, you have to go for grain size, Atterberg, specific gravity, Proctor compaction, soil dispersivity, permeability, shear strength, and one-dimensional consolidation. Now, you may say that, okay, all these tests we have carried out using the identification of the bore area. So, why to do them again? As I was saying in the starting also, construction of dams is a very slow process. Usually starts with the DPR, wherein the bore areas have been identified and certain investigations have been carried out. Now, in the current times, things are in a very better position, wherein we can mark those areas on Google Map, make them part of the DPR, have correct locations. But in previous times, the identifications of bore areas were like the bore area near to such and such village, or the bore area between these and these villages, or the bore area with a certain chuck number. And in times when the actual construction used to start, people were unable to identify those bore areas, and it was by sheer memory only that we said, yes, this road we used to go by this road, and from this road you used to take a left turn, and then from there maybe around 2 kilometers down the line certain region was identified. So before the construction, all these tests need to be redone to reassess, maybe not up to that much particular numbers, but a lesser number, to reassess and reassure that we are talking of the same body area for which we have done the design. So standard Proctor compaction, modified Proctor compaction, this we have done, studied. Then shear strength, we have different types, we can go in for them. Then dispersivity, Sherrard, chemical analysis, SS, all we have done. So all these tests we need to be going to. Then I'll just briefly go in through the quality control aspects of Terry Dam project. The 260.5 meter high Terry Dam. If you happen to visit the project, it's really beautiful. CSMRS was involved in the quality assurance of this project, and we used to visit once in a month there. Quality control was being done by the THDC personals. The contracting agency was, I think, Jayaprakash Associates. And if you visit there, you will really see that yes, it's like a man-made mountain which we have created there. Beautiful as such. Uh, we saw it from when we were at 600 level. The dam had to reach 820 level. I visited. You have visited. It's really, and so every month I used to go from CSMRS to Haridwar, and then from Haridwar you used to get down, and then from there 3 hours journey to the project site. And our first job was we used to go to the directly to the clay core, collect a sample, take it to the lab. And once the sample was secured in the lab, then we used to have our lunch. Because if we were collecting the sample after lunch, you would be getting the results. Every Monday we used to go, we would be getting the results late in the Friday evening. And Friday we used to go back to Delhi. So we always planned that we are getting the results by lunchtime, because when we were catching our train back from Haridwar, the Dehradun Shatabdi, the results of the grain size analysis should be with us. That's how we planned it up. So on the confluence of two rivers, the Bhilangna and the Bhagirathi, and this is how the dam looks after the filling. And these are the salient features: 260.5, base width around 1 kilometer, width at top 25 meters, length at top 592, upstream slope 2.5 horizontal is to 1 vertical, downstream slope 2 horizontal is to 1 vertical. And if you see these ramps, through these ramps the rock fill material was being transported both upstream and downstream. And when we were doing the quality assurance, we could feel that vibration of the rollers when it used to move past us. Typical cross section. Terry dam, it consists of a clay core, then there is the upstream fine filter, then upstream coarse filter, downstream fine filter, downstream coarse filter, and it's having an inspection gallery at the top, another inspection gallery here in the clay core, and then different types of shell materials. The utility of the filters is that it is not allowing the fines to move to the shell material. It's a transition. You have a fine grained soil, that is the clay core, then you are having the shell, which is a coarse grained soil. Now you should see that the fine grained soil does not migrate into the coarser particle. So you give a transition, and this transition is based on the filter design criteria, which is as per a IS code. So you have the grain size distribution of the clay material. From that grain size distribution, you define the grain size distribution which you require for the fine filters. You take the soil as a base material and you find the grain size for the fine filter. Then you take the fine filter as the base material and you decide the grain size distribution of the coarse filter. And from there you decide the grain size distribution of the shell material, and from there you decide the grain size of the riprap. This is how the design process is carried out. Because as I was saying that this dam has been constructed in region of high seismicity, that is 8.1 on the Richter scale, there was a possibility or thought that the shell material may liquefy. What is liquefaction? Liquefaction is a process in which under seismic loads the pore pressures get increased and the shear strength is reduced to zero. Okay, in simple terms. So it was thought that at a Richter scale or earthquake of 8.1 magnitude, there may be a possibility that even in the pervious shell material of having a permeability of 10 to minus 2 centimeter per second, because of the sudden changes in the forces, the pore pressures may not be dissipated so fast, and so there may be a possibility of liquefaction of the shell material. Okay, so a 10-meter thick riprap was laid on both the upstream and downstream slopes of the dam body. This is very typical of this particular dam. Usually ripraps are constructed having a thickness of 1.5 or 2 meters. But here the thickness of the riprap is 10 meters. And you see that this filter, this filter is only up to this level. Is it error in the drawing, or does it have some, or should it have some meaning? Uh, I'll give the answer. Okay, this question may be asked somewhere else. The coarse filter has been limited to this particular depth only because this is below the minimum drawdown level. Okay, this is below the minimum drawdown level. So means my drawdown level will never be below this particular depth. This much of water will always be there in the reservoir. This is how it has been designed. So that is the way it was. The filters have been optimized not to go it up to continuously up to the lower level. So this portion is going to be underwater always. If we consider a condition of sudden drawdown, yesterday we were looking at that in case of sudden drawdown, what happens? That this water level will be coming up to this particular level. So my clay is in a saturated condition. The water flow lines will be coming in this direction, and so this clay particle may migrate on the upstream side, but this fine filter and this coarse filter will be maintaining or restraining those clay particles to move out. Okay, so now as quality control, what we have to look into? We have to look into the clay core, the fine and coarse filter, and the shell material and the riprap. And what are the quantities we are talking of? 200 lakh cubic meter of shell material, 35 lakh cubic meter of clay core, 15 lakh cubic meter of filters, 30 lakh around cubic meter of riprap. So you can understand what is the dimensions we are trying to talk about. So what we decided? We decided that we'll have a density test, one density test per 800 cubic meter. In the previous slide I was saying 1000 cubic meters, so here we decided okay, let us have it at 800 cubic meter. Additional passes till required densities are achieved. In the contact zone, the density was design was or rather the word which we need to look in was 1.85, but in any case not less than 1.8. In the central zone 1.9, but not less than 1.85. Moisture content plus OMC 2% to 3% contact zone and OMC plus minus 1% in the central zone. Gradations, fines 5 to 15%, 10 to 20% in the contact zone. In situ permeability of the order 10 to minus 6 centimeter per second. Placement thickness 400 mm loose. minimum 8 passes of 15-ton vibratory roller, roller speed less than 3 km per hour. Now, how do you know that the roller speed is less than 3 km per hour? You are at the site. Now, how do you know? By judgment. What judgment? You know this is the length which we are talking. You can calculate what is the time it is taking for the roller to travel from that end to this end, and then you can calculate that. If you see it is near to 3 or less than 3, it is fine as per calculation. There may be certain error, but in case it is more than it, you have to restrict it. But why are we trying to restrict the roller speed? Because in case we are going for a higher roller speed, the impact of the compaction will not be adequate up to the full depth of the layer of the material. Then for the quality control, we had curves, upper bound and lower bound, and we always saw that the sample which was collected, the gradation is lying between these upper bounds and lower bounds. In case it was not lying between these upper bounds and lower bound, that particular layer of material was scrapped and thrown off. And these tests were done even at the borrow area first of all. So first level of error was reduced at the first of all at the borrow area, then at the stockpile, and then at the placement site. So stockpiles are always checked well in advance. So it was known that okay, stockpile A, B, C and D, they are going to be used for the next 1 month. So these tests were carried out before 1 month. So the stockpiles are ready 1 month before. The bore area is maybe ready 3 or 4 months before. And then you are going to work on the layers which are going to be placed. So all this planning is to be taken care by the quality control persons. That when I am going to test at the stockpiles, when I'll give okay for the stockpiles, because the contractor will say, okay, sir, whether I have to use this stockpile or this stockpile. She will say, okay, A, B and C are ready. You can take and use. You know the quantities can be used maybe in a period of 1.5 months. So you plan your testing for those. Then you plan the testing parallelly for the layers. So finally in the lab which we were talking about, you need to see that you are having enough persons and equipments so that these tests can be carried out in those labs. That much type of material and equipment should be available in the lab. Then fine filters, we said that relative density not less than 80%, minimum maximum density 1.7 to 2 gram per cc, coarse filter 1.7 to 2.06, moisture content watered freely at placement site, so it's to achieve 7% moisture content. Now how watering was being done? For the clay core, as I was saying, the moisture content in the bore area was known, then the moisture content in the stockpile that was calculated, and then from there the quantity of material which can be carried out in a particular truck that was known, and accordingly the quantity of water which is to be put into this truck which is carrying your material was calculated. And suppose this is my placement site. Far off from that place, we were having pumping sets wherein maybe some 200 liter or 300 liter water is to be poured into it, well sprinkled over the whole area of the truck. And then this truck used to go into this placement site. So there by here, when we are going to come at the placement site, your moisture content error is maybe up to a level of 1 or 2% only. So 1 or 2% of moisture content error can be taken care at the site itself. So again you have sprinklers, you maybe have 1 or 2 passes, have some sprinklers, then give some passes, and finally you are achieving the required moisture density and the moisture content. This is the whole process in which you are going to carry out your quality assurance. Gradation, fine filter, coarse filter, in situ permeability 10⁻³ to 10⁻². Placement, blended coarse and fine filter material mixed head side stockpile shall be placed in 400 mm loose, compacted by minimum 8 passes of 15-ton vibratory rollers. Now, even in the fine and coarse filters, in the trial embankments, you have to do you have to have that compaction by the vibratory rollers. Then you have to do a density test and gradation also. Why the gradation afterwards? To see that your fine filter material or coarse filter material is not breaking because of the compactive effort of the vibratory rollers, and that the fine percentages are limited to what you have used in the design. That you have to assure that. Shell material, again the average density was there, moisture content. The rate of water was around 250 liter per meter cube. Gradation shall have 600 mm maximum particle size, in situ permeability 10⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻ zones about 2 meter each of foundation rock and rock apartments. Maximum particle size of the shell material should not exceed 200 millimeters. Riprap, minimum density of 1.85, again freely watered. Placement layer 150 centimeter. 150 centimeter means 1.5 meters. Compacted minimum 8 passes. Gradation shall comprise of particle sizes varying from 5 mm to 1200. So maximum particle size is 1.2 meter. Now for Terry Dam, because as I was saying that high seismic zones were there, so gravelly material was mixed into clay to form GC, gravelly clay. Gravelly clay. Now, determining the in situ density of a gravelly clay material was a problem because it cannot be determined using a core cutter. So as I was saying before, that as a QC team, you have to devise sometimes different methods which are apart from the standard code of practices. So here what we used to do is that we used to dig out a piece of chunk from the clay core. Now this clay core material is having gravels also along with clay material. So we used to have two parts of it. One part of it was used for initial gradation to determine what is the gravel percentage, what is the clay percentage, and then how to determine the in situ density. So this portion was taken out. Then this piece or lump of soil was dipped in molten wax so as to have a thin layer of wax covering it, because we wanted to know its density by water replacement method. If you are going to put this soil lump in water, it will get disintegrated. So you cover with molten wax around it, and there also the dip was standardized into maybe 30-second dip, because if you are going to put it for more, the quantity of wax will be more. And a correction factor was also then devised after a series of tests, that okay, how much correction is going to be put for the wax material also. This is what I was trying to say, that special methods have to be devised, and then this wax coated lump of soil was then weighed, put into a cane sort of a thing, and then through a special arrangement of a water replacement method connected to a weighing balance, it was dipped in water, and then the buoyant weight noted and the density, the quantity of waters which was replaced, so the volume was known and the weight, and then the gradation. Again, for permeability of shell, as I was saying, water replacement method. So you have a ring and water replacement method. That was the standard practice which was being used in the dam. We got these things constructed at the site itself. A bigger ring and then a pointer system, and a pointer which is having a graduated mark also. So every time you are going to fix that, okay, this much is the level of water which we will be going in for. I think Shahid will be taking care of, he will be explaining this test a bit in more details. because it is the water. It's a simple test as such, but it requires attention also to carry out, and then the gradation. So inside tests were being done. Corrections were even taken care for the polythene which was used for doing this test by some standard method, standard samples also. So initially those tests were carried out, then the correction in the polythene volume, because Terry Dam was supposed to be a dam with the highest quality, to be built with the highest quality. So every precaution was kept there, every minutest thing was taken into care to understand that what are the values which are we are achieving. This is another project, Coal Dam. I think we are how much? What time? It's 1:15. Do I go with Coal Dam or I skip the Coal Dam? I think I'll go for Garada Dam. I'll go for another dam, which is the Garada Dam. I'll remove Salma. Okay, just a case study. Garada Dam, Bundi, Rajasthan. This, if you remember this slide which we were talking, the failures which had occurred in our country. The last which we were having, even though there were much more, Garada Dam failure, it occurred in 2010. It occurred on 15th August 2010. And what is this dam basically? It's a earthen dam as such. There are three rivers which are coming and confluencing and forming the main gorge portion here. And this is the failed structure of the Garada Dam. A portion of around 100-meter length breached, and this is the vertical face of the dam which you can see, around 4.5 kilometer long dam. Initially it was told that it is a zone dam consisting of a core shell material at both the sides, a chimney filter and horizontal drain here, and clay material in between as the core. Another typical section of it, we visited this project. We did health assessment of the dam and itself, the remaining portion, and actually this is what we were told: the riprap, the shell, the core, horizontal drain, chimney. But when we did the investigation, we could not find any of these. Basically, we found that it is a homogeneous dam as such, and that too the material which was told used to be constructed was not the one which it was used to for actual construction. Lot of investigations were done by CSMRS, and these are the cracks from the upstream to the downstream. Maybe these may be the causes of failure. No proper grouting was done, no consolidation grouting was done, there was no cut-off trench, nothing of those sorts which are there available in the design. And here the failure of the dam was also because of the overconfidence of the people there. It was felt that the river which is flowing on which the dam is being constructed, the water availability is very less. But during that particular year, there was lot of rainfall which occurred, which led to the rise in the water level in the reservoir. And before the reported failure, the reservoir had recorded a rise of 6 feet, and at the time of the failure also the reservoir was on the rising trend. So many investigations were done. We found cracks, if you see here, like these upstream cracks were found. We were able to see those cracks on both the upstream and downstream slope, indicating that the slopes are not in a stable condition. And once the structure gets subjected to again filling of reservoir, it may fail. So you are now in a situation of rehabilitating a structure about which you are not confident on the density, you are not confident on the material, you are not confident what are the depths of the cracks, and that is a real big problem. So the thing was taken care by Central Water Commission. We ourselves, project authorities, played a relatively smaller role in it, and finally it was thought of that okay, we'll identify the structure into two portions: the breached portion and the unbreached portion. And in the unbreached portion, it was decided that part of the structure will be removed and rebuilt, and in the breached portion the whole structure will be rebuilt. And the part of the structure which is to be rebuilt, a fresh layer of horizontal and vertical filter will be introduced. In order to be more cautious, a layer of non-woven geotextile was also introduced in between. And then also, because the material properties were not known as such, so the upstream face of the dam was covered with geomembrane. So the idea was that initially we will not allow any water to percolate into the dam body, so that as such the structure is safe in the dry condition. If at all water percolates into the dam body, then we are introducing filters on the downstream side so as to collect that water and drain it effectively. And then the portion which has been cut and rebuilt, there the compaction density has been achieved to what is required. So these were the three measures which were decided and used and executed. And the slope, initially this was the failed slope, then it was cut to a slope of 1:4, and then geomembrane put on it. We did some quality control tests also in between. Luckily the contracting agency was also trying to build the dam, and he did works to its proper requirements. So this is a sample collection which we are doing here in the constructed portion. And one thing I would like to add here, which we really saw in that project, was that this is a geotextile layer, huh? So this is a geotextile layer here also, here also. And the field laborers, what they were usually doing it, that they were always, when they were going for lunch time, they were usually keeping their tools on the geotextile. Why geotextile? Because it is easy to identify their tools and it's not going to get lost in the mud. And how usually labor are going to place the tools? Not, they are not going to go gently placing the tool, they'll just throw it. Now you imagine you are having a spade, and you are having a kudal, and you are just throwing into it. And where you are throwing it? You are throwing it on a geotextile which has to act as a barrier for the migration of the fines, and you are puncturing it with the tools. And the contracting agency and the project authorities are unable to visualize these things. So during one of the visits, when we went there, and when we saw this phenomena, we told these people, "Bhai, you have to take care of this, because this is your lifeline. This particular geotextile is now your lifeline. If you are going to puncture it from here, this may be again a point of weakness, and your whole structure will again fail." So maybe I think because the structure is standing now, I think they might have taken care of it. But at times these are also things which we need to look into, because it becomes a very beautiful layer which attracts you to keep things on it. So that we have to take care. So finally, again, then there was a layer of geomembrane, and in order to protect this geomembrane from puncturing, a geotextile was introduced in between, so that the geomembrane doesn't get punctured. Then grouting was carried out, rock toe was again rebuilt, and finally the structure was complete. And this is now the recent photograph of the Granite Dam. This is another structure which we have come across. It is a very precarious situation. The structure has failed. Here the contracting agency could not demarcate between the shell material and the clay material. They thought that dam is a dam, and if they have built the dam up to a certain height, it will be able to stop the water. The clay zone was built up to a lesser heights. Floods came, they percolated through the silty zones or the shell material, and the whole clay was washed away. And then you can see that this clay material, which actually had to be here, is the water flowing out through it, and the whole slushy clay moving out. These were certain attempts made by people to stop the flow of clay, but finally, this is what happened. And this. So, this happens because of lack of understanding. As you are saying, that is it possible that even now people do not understand? Yes, it is possible. People still do not understand some of the intricacies of dam constructions. People do not understand that how material handling is important. People do not understand that characterization of material is important, and such things occur. Investigations are being carried out at CSMRS for this particular structure. As you can see here, this is the shell material and this is the clay. The clay has been built up to this level only, and this got washed off. So, conclusions, we can say construction quality control is a vital role. Management and exploration of bore area. Queries as per specification requirements also play a vital role. Quality control test records from essential requirements for safety and post construction monitoring, maintenance of dam structures. Soil testing and quality control are essential to ascertain the suitability of bore area materials for construction of earthen embankments and evaluation of strength and compressibility characteristics of bore area and foundation material. Quality control people are always taken as parents to children. Quality control people tell the children, like parents tell the children, you have to study in order to success. The quality control people also tell the construction people that you have to take care to achieve success. But at times, as children ignore the sayings of the parents, the construction people also ignore the sayings of the quality control people. So you have to be consistent in telling those things. Continuous inspection has to be there of the foundation abutment preparations, material processes, embankment construction, comprehensive quality testing program. Review for quality control, dewatering, drainage works, haul roads, inspection of actual operations. We have seen in projects wherein people have been using clay core as roads. Even after repeatedly telling them not to use the clay core as road, they use them as roads because if they are going to use the shell material for making transportation of their trucks, the tires get punctured, so they start using the core. Even though as per standard practice, they should use some steel plates to cross the clay core, and they should have layers of steel plates or some other material on the shell material to move in. There have been examples wherein some finer materials were placed on the shell material and were not removed, leading to development of pore pressures and failures also. All this thing indicates that two things. Number one, either the quality control people are not there at site, or there is a lack of understanding of even the quality control people on the behavior of these additional materials which have been put for the construction processes. So, adequate construction record should be there, preparation of complete reports, records of test results, photographic evidences, evaluate claims by contractor to determine the possible causes of distress. During construction, design engineers should frequently reassess design concepts, frequent visits, observe actual conditions and construction procedures. Design evaluation must include analysis of compaction control test results. That's all. So it is a difficult task as quality control engineers, but it is worth a task because it is the task as quality control engineers which actually is leading to the successful completion of the projects which we are relishing as citizens of this country. Thank you.